What are moles? What is Avogadro's number? What is relative formula mass? To be able to understand moles, you first need to understand what relative atomic mass and relative molecular mass are. So, relative atomic mass is a standardized way of representing the mass or weight of an atom of an element in the periodic table. So if you look at the key here for this periodic table, the relative atomic mass is the number above the atomic symbol. So if we take zinc, for example, the relative atomic mass of an atom of zinc is 65. Aluminium would be 27, and the relative atomic mass of an atom of oxygen is 16. The relative molecular mass is a standardized way of representing the mass or weight of a molecule of a substance. So, for example, if you take water, which has molecular formula H2O, the relative molecular mass of water is 2 multiplied by the relative atomic mass of each of these 2 hydrogen atoms, which is 1, 2 times 1, plus the relative atomic mass of this single oxygen atom, which is 16. 2 times 1 is 2, plus 16 is 18. Then if you wanted to calculate the relative molecular mass of, for example, hydrogen chloride, which is HCl, then that would be the relative atomic mass of a hydrogen atom, which is 1, plus the relative atomic mass of an atom of chlorine, which is 35.5, giving you a total of 36.5 for the relative molecular mass of hydrogen chloride. Relative formula mass is exactly the same. So if you need to calculate the relative formula mass of hydrogen chloride or hydrochloric acid, it would be 1 for the hydrogen plus 35.5 for the chlorine, so 36.5, and the relative formula mass of or RFM of water would be 18. In GCSE, though, you need to be able to calculate the RFM of more complicated formula than those examples. So say, for example, you needed to find the RFM of aluminium sulfate, which has a formula Al2 SO4 3. Then to figure out its RFM, you need to add together the relative atomic masses of all of the different atoms of elements involved. So there are 2 atoms of aluminium, Al2. So first you need to do 2 multiplied by 27, which is the relative atomic mass, or RAM, of aluminium. So 2 times 27 for the aluminium, plus sulfur. There's 1 atom of sulfur inside the brackets, but you have a 3 outside the bracket, so that means in total you have 3 sulfur atoms. So 3 multiplied by, just go back up to the periodic table to find the RAM of sulfur, which is 32. So 3 times 32 plus, and then oxygen. So there are 4 oxygen atoms inside the brackets. There's a 3 outside the bracket, so it means you have 3 lots of SO4. So that means you have 4 multiplied by 3, which is 12 atoms of oxygen. So plus 12 times the RAM, or relative atomic mass of oxygen, which is, from the periodic table, 16. And then you just add these together. 2 times 27 is 54, plus 3 times 32 is 96, plus, and I'll use my calculator to work out 12 times 16, which is 192. So then add those up for the total. So the RFM of aluminium sulfate equals 54 plus 96 plus 192 equals 342. So now that we've gone through the concepts of relative atomic mass, relative molecular mass, and relative formula mass, we should be better able to understand what a mole is. So what is a mole? So a mole is an amount of a substance, any substance, that contains a specific number of particles. So a mole is an amount of a substance that contains the same specific number of particles. What is this specific number of particles? So this number of particles is known as the Avogadro number or Avogadro constant. It can be represented as n subscript a, and it equals 6.02 times 10 to the 23, which can be rounded or approximated to 6 times 10 to the 23. So bringing that back to the explanation of what a mole is. So a mole is an amount of a substance that contains the Avogadro number of particles, or, putting it another way, 1 mole of any substance contains 6.02 times 10 to the 23 particles. Or approximately 6 times 10 to the 23 particles. What does 6.02 or 6 times 10 to the 23 mean in real terms, in real life terms? That's a 6 with 23 zeros after it, so that's a huge number. So the Avogadro constant is this number of particles. And 1 mole of any substance contains this number of particles. So that leads you on to the next question. What is a particle? So a particle can be one of several things. A particle can be an atom, a molecule, an ion, or a formula unit. You don't need to worry about formula units so much for GCSE, but we'll get onto an explanation of what that is a bit later. So an atom, which is a single particle. So for example, you could have a sodium atom, represented like that. A molecule is 2 or more atoms bonded together. So an example of this could be a water molecule, which is a hydrogen bonded to an oxygen, which is bonded to another hydrogen, H2O. An ion is an atom that has either lost or gained electrons to become positively or negatively charged. So an example of this could be a magnesium ion, Mg. A magnesium atom loses 2 electrons to become a magnesium ion, so it would have a 2 plus charge. And a formula unit. So for GCSE purposes, really, you only need to think of a formula unit as being the chemical formula you'd see for any substance in a chemical equation. So as an example, you could take sodium chloride, which is NaCl. That's its chemical formula. It's not a molecule. There's no such thing as a molecule of sodium chloride because sodium chloride is an ionic compound. So there is no fixed number of sodium and chloride ions in a molecule of sodium chloride. But the simplest possible representation of the structure of sodium chloride is NaCl. So that would be considered a single formula unit of sodium chloride would be NaCl. Okay, so again, going back to the definition of a mole. So a mole is the amount of a substance that contains 6.02 times 10 to the 23 particles. Those particles being either atoms, molecules, ions, or formula units. This brings us on to what the 2 most useful things you need to know about moles for the GCSE exam. So the 2 most useful things about moles for GCSE are: one, these are 2 things you should definitely remember. 1 mole of any substance weighs its relative formula mass, or RFM, in grams. Take an example of this. From before, we calculated that the RFM of water is 18 because 2 multiplied by the RAM of each hydrogen, 1, 2 times 1 is 2, plus 16, relative atomic mass of an oxygen atom is 18. So if you have 1 mole of water, it would weigh 18 grams. This is true for any substance you're dealing with. If you had 1 mole of sodium atoms, that would weigh the RFM of sodium in grams. So, you could do that as another example. 1 mole of Na atoms weighs, so the RFM of sodium, go back up to the periodic table to remind ourselves of what the relative atomic mass of sodium is. So from the table, relative atomic mass of sodium is 23. So going back down. So this means that 1 mole of sodium atoms weighs its RFM 23 in grams. So that's the first most useful thing you need to know about moles for GCSE. The second thing is the formula that's derived from everything we've talked about before. And this formula is that the number of moles equals the mass of whatever substance you're dealing with in grams over the RFM of that substance. or N, number of moles, equals mass, M in grams, over RFM. Okay, so we'll get on to some pretty simple example questions that use this formula. Okay, so if you have a sugar addiction, a pretty severe sugar addiction, this is the type of question you might want the answer to. So how many moles are there in 2 kilograms of glucose? Okay, so the answer to this. So you'd be using the formula N, number of moles, equals mass of the substance you have in grams over the RFM of that substance. So here we know the mass is 2 kilograms, but the mass in this formula has to be in grams. So there are 1,000 grams in 1 kilogram. So 2 times 1,000 is 2,000 grams over the RFM of glucose. So the molecular formula for glucose is C6H12O6. So its RFM equals 6 multiplied by the relative atomic mass of carbon, which is 12, plus 6 multiplied by 1, the relative atomic mass of hydrogen, plus 6 atoms of oxygen, so 6 multiplied by 16, the RAM of oxygen. So that is 72 plus 6. Oh, just one mistake here. That shouldn't be 6 times 1. That should be 12 times 1 because there are 12 atoms of hydrogen. So 12 times 1 is 12 plus 6 multiplied by 16, which I'll work out in my calculator. 96. And then adding these together, you get 72 plus 12 plus 96 equals 180. So that's the RFM of glucose. So finally, we can figure out the number of moles of glucose. So N equals 2,000 grams over 180, the RFM of glucose, which is, again, calculator, 2,000 divided by 180, 11.1. So 11.1 moles. So it would take 11.1 moles of glucose for you to satisfy your severe sugar addiction. Another question using this formula again. What is the mass of 25 moles of gold? So you could be trying to smuggle gold through Heathrow Airport, but I wouldn't advise that. That is completely illegal. But somehow you've acquired 25 moles of gold. Could be through legitimate means or creative means, but that's none of my business. I'm just here to teach chemistry. So we know that we're trying to calculate the mass. We know how many moles there are. So whenever you see the words mass and moles in a chemistry question, then usually it involves this equation. So N, number of moles, equals mass in grams over the RFM, relative formula mass. In this case, we know we have 25 moles. That equals the mass, which is what we need to calculate, but we don't know. So mass grams over the RFM of gold. So I'll go back up to the periodic table to see what the relative atomic mass of gold is. It's a long way up. Okay, so here is gold, AU, and that has an RAM of 197. So go back down, put that in our formula. Oh, 197. Just check that again. Yep, 197. Okay. So gold is AU. And as with all metals, it just, for the purposes of these equations, it just exists as single atoms. So AU RFM equals 197. Okay, so now we need to rearrange this equation to make mass the subject, and all you have to do there is to multiply 25 by 197. So 25 multiplied by 197 equals mass of gold, which is 25 times 197, 4,925 grams. So that is almost 5 kilograms of gold that you're trying to smuggle through the airport, which I don't advise. What would be interesting would be to figure out what would be today's valuation if you had 4,925 grams of gold. So looking up today's price, one kilogram of gold today, which is the 14th of February, Valentine's Day, would be a nice present to get. 90,006 euros and 50 cents. 90,006 euros and 50 cents. So to figure out the value of that, you'd have to do 4.925 kilos multiplied by 90,006 euros and 50 cents. 4.925 times 90,006.5 equals. That's a lot of love for your partner for you to risk smuggling all of this gold, because it has a value of 443,282 euros. So you must really love your partner an awful lot. But again, I don't advise doing this. It's illegal. Plus, you also have to figure out import taxes. Getting that much gold across customs, import taxes. Then are you going to take it on your carry-on luggage, or are you going to have to pay a supplement to put it in your checked luggage? These are all things to think about, decisions that you'd have to make at the end. But yeah, that's another matter. So this is how useful moles can be, the equation for moles specifically. So knowing that n, the number of moles, equals the mass over the RFM of the substance, and that is an equation that you'll be using very often throughout GCSE Chemistry, and especially when it comes to answering calculations involving masses, moles, etc. Another type of question that they can ask you that's related to this is to do with the Avogadro number. So how can this be used in questions, Avogadro number? So an example question you could be asked here would be, how many chloride ions are present in 2 moles of sodium chloride. Okay, so the answer. So the first thing you need to do to be able to work out the answer to this question is what is the formula of sodium chloride? So that's NaCl, the chemical formula. You know you have 2 moles. So firstly, using the Avogadro number, so we know the Avogadro number is 6.02 times 10 to the power 23. So if we had 1 mole of sodium chloride, of NaCl, that would contain you would have 6.02 times 10 to the 23 sodium chloride formula units, or 6.02 times 10 to the 23 lots of this. So that would mean you would have 6.02 times 10 to the 23 sodium atoms or ions, strictly speaking, but you would also have 6.02 times 10 to the 23 chloride ions, because you'd have 6.02 times 10 to the 3 in total of these formula units. So one of these, one formula unit of NaCl consists of 1 ion of sodium and 1 ion of chloride, or 1 chloride ion. So if you had a mole of sodium chloride, you'd have 6 with 23 zeros after it sodium ions and 6 with 23 zeros after it chloride ions. But in this question, it's 2 moles. We're told we have 2 moles. So 2 moles of NaCl contains 2 times 6.02 times 10 to the 23 Na plus ions and 2 times 6.02 times 10 to the 23 chloride ions, or Cl minus ions. So putting this in the calculator, don't need to use the calculator for this one. So that would be 12.04 times 10 to the 23. Putting that into standard form, it would be 1.204 times 10 to the 24 chloride ions. You'd also have this number of sodium ions as well, but the question wasn't asking that. The question was just asking about chloride ions. But I think it's useful to understand that you would have the same number of sodium ions and chloride ions, and it would be this amount. Slightly trickier example question is this. So how many fluoride ions are present in 3.5 moles of aluminium fluoride, which has the chemical formula AlF3. A for answer. So just like sodium chloride, aluminium fluoride is also an ionic compound. So there's no such thing as a molecule of AlF3, no such thing as a molecule of NaCl, but you can consider this a formula unit of aluminium fluoride. So a formula unit of aluminium fluoride consists of one aluminium. In this case, it's an ion because it's ionic. The charge of an aluminium ion is 3+, and you have 3 fluoride ions. So what this means, if you had 1 mole of aluminium fluoride, it would contain the Avogadro number of formula units. So it would contain 6.02 times 10 to the 23. You would have 6.02 times 10 to the 23 units of AlF3. But within each, I'll write this here, of AlF3 formula units, however, in here, so one formula unit represented by this consists of 1 aluminium ion and 3 fluoride ions. So if you have, say you had one of these, one formula unit, you'd have 1 aluminium ion and 3 fluoride ions. If you had 2 of these, you'd have 2 aluminium ions and 6 fluoride ions. So 1 mole of aluminium fluoride would have 6.02 times 10 to the 23 lots of this, which means you would have 3 multiplied by this lots of fluoride ions, because every one of these has 3 fluorides associated with it. So to calculate the number of fluoride F- ions in 3.5 moles, of AlF3, you would do this. So it's 3.5 moles multiplied by the number of fluoride ions per formula unit, which is 3, multiplied by the Avogadro number of particles, which is 6.02 times 10 to the 23, which equals, back to the calculator, 3.5 times 3 times 6.02 times 10 to the power 23 equals 6.32 times 10 to the power 24 fluoride ions. So in real number terms, that would be roughly 6 with 24 zeros after it. So that, again, is a pretty big number. So I hope you found this helpful. And if you did, then please like and subscribe. And also consider checking out my website, the link of which is below the video. See you with the next one.